Hi everyone. In this video we're going to work on a little bit of function notation review. You're going to use this notation really heavily, especially at the beginning of calculus. So we're given a function here, g of t equals 5t minus t squared. And you just want to take that rule really seriously. That says whatever I input, it's going to get multiplied by 5, and then I'm going to subtract the square of my input. So we've been using our function notation with trig as well, but it's a little bit different than when we use it with polynomial and rational functions. So we're just going to refresh that. Okay, so part A is asking me to use t plus 3 as my input. And if I do that, I'm supposed to take that input and multiply it by 5 and then subtract the square of that input. So again, just always, whenever you see g, following the rule that you were given. And the simplify here is our usual stuff. I'm going to go ahead and distribute through parentheses and get 5t plus 15. And then I'm going to be really careful here. I'm going to square first. Remember, minus signs are attached by multiplication. So we want to apply exponents before multiplication. Squaring that gives me t squared plus 6t plus 9. Don't forget that that's t plus 3 times t plus 3. So you can't distribute powers. You have to actually FOIL that out. That's where the 6t is coming from. And then I'm going to carefully do that subtraction. So I'm actually going to write it out one more time and say that's going to become a minus t squared minus 6t minus 9, which means in the end I have a negative t squared, and then 5t minus 6t is negative t, and 15 minus 9 is positive 6. And that's my final answer. You do not have to factor to simplify things. The only time that's coming to mind right now when I think you should factor to try and simplify is when you've got a fraction, because then you might be able to factor and cancel. Otherwise, it's not more or less simplified to factor that, I would say. I guess I can think of one more time. If you're solving, like we were just doing, absolutely factor, that's great. But just to simplify, not necessarily required. For part B, we're supposed to take function g of t and set it equal to 3t and then solve. So function g of t is a 5t minus t squared, and we're setting that equal to 3t. So this is actually an equation. I'm going to approach it a little bit differently. I'd like to set this equal to 0. Whenever I've got that quadratic, I want to try and set it equal to 0, with the exception being if there's only a single t, then I'm going to use square roots. I'm going to use inverse operations. To get that t squared to be positive, I'm going to move everything to the right. So I'm adding a t squared, and I'm subtracting 5t from 3t, so it becomes a negative 2t. And then we're going to factor a t out of that. This is actually a simpler factoring, but a lot of times people will kind of trick themselves and think it should be messier and try and do 2 sets of parentheses. So just remember, always look for that greatest common factor. Another little pointer here is I see a lot of people not set it equal to 0, but write it this way, and then they want to divide everything by t. And my warning would be anytime you divide out something that includes a variable, you could be losing a solution. And this would absolutely be true here. You'd lose the solution t equals 0 if you did that. So do that factoring method instead, set it equal to 0. So it looks like t equals 0 or t equals positive 2 are our answers for part B. Okay, and then part C, this is the real big one for calculus, the difference quotient. This is telling something about average rate of change or slope of a function. So let's see, we need to just do the algebra here. Calculus will get a lot more into the meaning. But the algebra is going to involve plugging a t plus h into g, and then plugging a t into g and subtracting. So when I plug t plus h into g, I get 5 times my t plus h minus my t plus h squared. And then I need to subtract off what I get when I plug a plain old, I'm going to put brackets so this is a little clear, a plain old t in, which is just my original function. G of t is my original 5t minus t squared. And then I need to divide all that by h. So hopefully you've worked on this in your pre-calc 1, but it can still be a little messy. So we're just going to practice again and really think about your algebra here and your setup. If you don't get it set up right, then it doesn't matter what algebra you do. It's not going to work out correctly. Okay, and from there, our goal is to simplify until we can cancel out this lone h in the bottom. And where we're headed in calculus is we want to let that h equal 0, and that's why we need to cancel it out. So we'll get a 5t plus 5h. And then I'm going to be really careful again here. I want to subtract t plus h squared. So I first need to figure out what t plus h squared is. And it turns out it's t squared plus 2ht plus h squared. Again, just remember you can do that as side work if needed. We're doing t plus h times t plus h. So we're going to have our first t squared. Our outside and our inside are both t times h. That's where the 2ht comes from. And then our last is h squared. And then we are subtracting 5t, but we end up adding t squared. And then we'll have to divide all that by h. And our goal is that that h is going to go away by the time we're done. Okay, so I'm going to write it out once more, but if you're very careful, you can also just start working on some of the addition, subtraction. Actually, I take it back. I am going to do one thing now, since it's not in parentheses. Let's pick a color here. This 5t and this minus 5t, there's no parentheses or anything holding that into the fraction, so we're going to go ahead and just drop those out. So we'll be left with a 5h minus a t squared plus a 2ht plus an h. Oh, hold on. I'm already messing it up. I'm supposed to be distributing that sign through. It's minus a 2ht minus an h squared. And then we have a plus t squared at the very end that we don't want to lose track of. And once again, we have some things drop out of the fraction. We have a minus t squared plus t squared. And that's about as far as we get with dropping things out right now. But what I do notice, and this is really important, if this doesn't happen, something's gone wrong along the way. Every term remaining in the top has an h in it. So we can factor an h out now. And that's always the goal, is to be able to factor an h out of the top and cancel. So that's going to leave us with a 5, and then a minus 2t from the 2ht, and then a minus h. And it's okay that there's still an h in there. The goal isn't to get rid of all h's, it's to get rid of that lonely h on the bottom that would prevent us from plugging in h equals 0. So h's are gone, and our final answer is 5 minus 2t minus h. And that's a beautiful answer. Again, it's fine to have h's in there. We just don't want to have the lone factor of h in the denominator. All right, thanks for